This video is on vertex form. I'm going to do a couple of practice problems on here. This first one, we're going to find some information and we're going to graph it. Make sure you can actually graph them even if we don't know what the x-intercepts are. And then we're also going to be writing the equation in vertex form and being able to convert as well. So on this first one, we're given the form f of x equals 2 parentheses x minus 2 squared minus 3. We want to find the vertex. This is in vertex form. So our vertex, remember, is change h, keep k. So we're going to change the h value from inside. That becomes a positive 2. We're going to keep the k on the outside, which is a negative 3. So our vertex is at 2, negative 3. The next thing we're going to find is the axis of symmetry, which we know is still the x value of our vertex. So we automatically have it. So x equals positive 2. Next up is the domain. It is still a quadratic, so all domains of quadratics are negative infinity to positive infinity with open brackets. The range, we know, will have to depend on our vertex and if it opens up or down. So we didn't say what A was. A is a positive 2 right now. So if it's a positive, that means we're going to have a positive infinity, which is always on the right-hand side. And then the value is the y of your vertex, so that's that negative 3. So close bracket on the negative 3. Next is our y-intercept. In order to find the y-intercept, you need to plug in 0 into the x value and then just solve. So if I do that, it's 0 minus 2 is negative 2. Then you square it, that's a positive 4. Then you multiply it by 2, which is a positive 8. And then you subtract 3, which is a positive 5. So our y-intercept is actually at 0, comma, positive 5. Because we plug 0 in, we got 5 out. So again, plug 0 in, and you end up getting 5. Transformations. Transformations, again, come from your vertex and the a value. So let's look at which way it moves first. So from 0, 0, how do we get to 2, negative 3 from 0, 0? So from 0, 0, we want to go to 2, which means we go right 2. But then we wanted to go to negative 3 on the y, which is going down 3. So right 2, down 3. That's just from the vertex. But then the other thing is looking at the a value. So if we look at our a value, a is equal to a positive 2. So we can actually write this up at the top. A equals a positive, a equals a 2, h equals 2, and k equals negative 3. If we write that out, we have all the information we need. We have the h for our vertex, our k for our vertex. The positive tells us that it is not reflecting. There is no reflection. But a is 2, therefore it does do something. It's either a vertical stretch or compress. Since 2 is bigger than 1, it's going to be a vertical stretch. So it's a vertical stretch of 2. That's the a value right here. Now, if it had been 1/2, it would have been a vertical compress of 1/2. So whatever that a value is, this part, the positive part of it, tells you what it of what. Now, before I go over into the graph, let's actually get our table of coordinates because we don't have many. We only have 2 coordinates. We have 5 spots here. We have x and y. Your vertex, since it's the middle of your graph, you should put your vertex in the middle of the table. So I'm going to put 2, negative 3 in the middle of this table. So I have 1, 2, 3, 4, 5 spots. So 2, negative 3 is going to go right here. What I want to do is I want to go to the left, 2 spots to the left of the vertex and 2 spots to the right of the vertex. And it's just a number line. It's just like if we have the x value, we can plug it in to find the y, like how we did with vertex and how we did with y-intercept many times before. all I have to do is get values of x. I can pick any values of x, and I will actually solve to get the y value. So if I pick, let's say, I would just want to go to the right of 2. I'm going to go to 3, and then I want to go to 4. Then if I want to go to the left of 2, I'm just going to count down by 1. So I'm going to go down 2, 1, and then 0. Now all I have to do is plug these values in, and to get the y value. Because I went up 1 and then 1 more, I went down 1 and down 1 more, these are the same distances away from the vertex. So 4 and 0 are the same distance away, and 1 and 3 are the same distances away. Therefore, the y values will mirror each other at the 3 and 1 and at the 4 and 0. These will mirror each other, the y values. And I actually already have 0, 5, so I can put this y value of 5 already. Then, since 0 and 4 are the same distance away, the y values have to be the same. So it's going to be 4, 5. That means I only really have to find one extra coordinate. So if I plug in either of these coordinates, I will find the y value. So I'm going to start with the 3 because it's actually bigger than the 2. So if I do 3 and plug it in, 3 minus 2 is 1. 1 squared is just 1. 1 times 2 is 2. 2 minus 3 is negative 1. So that means that this coordinate is at -3, -1. Since 1 and 3 are the same distance away, the y values here have to mirror each other. So this also has to be at a -1. All you do is just plug in the x values to get the y's. That's how you always do that. So now we can go and graph it. So on my coordinate plane, I need to label the axes x and y. I need to have my scale because I don't have any numbers on it. I don't have any numbers that are too large, so I'm just going to count by 1. So count by 1s. I am going to go ahead and plot my coordinates. I have 0, 5, 1, 2, 3, 4, 5. Here's my y-intercept. 1, -1, 2, -3, 3, -1, and then 4, 5. I also need to draw in my axis of symmetry so I can see that those are the same distances away from the axis of symmetry. So it is a mirror of each other. So this is AOS x equals 2. So x equals 2. Now, these 1 and 1 away, 1, 2, 1, 2. They are mirrored from each other. That means these are correct. I have 5 coordinates, and now I can actually draw my parabola. I can connect them. This is opening up. I went right 2 and then down 3 to get to my vertex. There is no reflection, it's not reflected over, and it is more narrow than a normal parabola. This is how you get the extra coordinates to be able to graph. On this next problem, we're going to write the equation in vertex form for the quadratic function that would pass through. So on here, write the equation. Again, that's when the x and y are still letters in your answer. We want to put it in vertex form. So vertex form, again, looks like function notation. That's the y equals a parentheses x minus h parentheses squared plus k. We have the letters y, a, x, h, and k. So that's 5 letters again. That is 5 letters. So we have h equals, k equals, x equals, y equals, and a equals. The same way we did it before with intercept form. Right now, so the vertex gives us our h and k. This is h, this is k. And a random point gives us our x and our y. So h is equal to -2, k is equal to -5, x is equal to -6, and y is equal to 0. We don't know A yet. So we're going to plug them in. Y is equal to 0 equals, we don't know A yet, parentheses, x is negative 6, minus h, so that's going to be minus a negative 2, which is plus 2, parentheses squared, and then plus a negative 5, so that's just minus 5. So we have 0 equals A times, that's negative 6 plus 2 is negative 4, squared, minus 5. Now the thing is that we cannot, this is multiplication right here. We cannot just subtract 5 from that. So you actually want to go ahead and move that 5 to the other side so that we don't accidentally multiply it. Let's just add this 5 over here. 5 equals A times, so negative 4 squared is 16. So we really have 5 equals 16A. We want to divide by that 16. A equals 5 over 16. We're going to write our equation now, and if we remember, we don't use the numbers for x and y, we only use the numbers for A, H, and K now, because x and y will be letters. So our answer will be y equals 5 over 16, parentheses, we keep our x as a letter, minus the h, which is minus negative 2, so that's plus 2, parentheses squared, and then minus 5. And this is our final answer. Okay, so again, the reason why you want to go ahead and move this 5 over, this is multiplication, and then this is subtraction. You cannot turn that into an 11. That's not the same thing at all. So we're going to do this one as well. So we're going to write out our h equals, k equals, x equals, y equals, and a equals. So the vertex tells you your h and k, so h is 1, k is 3, and then we have a random point which tells us our x and y. So h is equal to 1, k is 3, x is 2, y is 5, and we do not know a yet. We're going to plug it into this same equation up here, so I'm not going to rewrite that. I'm just going to do the blue. Y is 5 equals, we don't know a, parentheses, x is 2, minus h, so that's minus 1, parentheses squared, plus k, so it's going to be plus 3. We have 5 equals a times 1 squared plus 3. Now again, we want to go ahead and move that 3 over, so we're going to subtract that 3 real quick. We're going to end up having 2 equals a times 1, because 1 squared is 1. So we have 2 equals 1a. Therefore, a is equal to 2. A equals 2. Because if you divide by 1, it's still going to be 2. Let's write our equation. We're going to use the numbers for h and k and a. We're going to use letters for x and y. So we'll have y equals 2, parentheses, x, minus h, so minus 1, parentheses squared, plus k, which is plus 3. And that is our final equation. We can also write this in function notation as well by just changing this to get rid of the y. We'd put 2f of x minus 1 plus 3. That's how we write the equation into vertex form. This next question, it says convert it back into standard form. So again, we're going to go back and distribute. We want to get no parentheses. Now if we look at this problem, we have multiple different things. We want to get rid of the parentheses, but do you notice we have a square on the parentheses? This square on the parentheses is what you have to get rid of first, actually. What this does, the squared means you have to write it twice. So we really have negative 2, parentheses, x plus 1, and then times x plus 1 again, and then minus 10. So this is what happens with the parentheses up there, with that squared. So now when we do this, we have that negative 2, because we wanted to get rid of the parentheses first, and that bracket, x plus 1 times x plus 1, close that bracket, and then minus 10 on the outside. So let's focus on the inside first. We're going to distribute like we did before, x times x times 1. So we'll have that negative 2 bracket. X times x is x squared. X times 1 is 1x. Then we will distribute the 1 to everything. 1 times x and 1 times 1. So plus 1x, and then plus 1 times 1 is only 1. Close bracket, and then minus 10 on the outside. We're going to combine our like terms. We have negative 2, we have that bracket, x squared plus 2x plus 1, bracket, minus 10. Now we got rid of the parentheses, but now we got to get rid of this bracket as well. So we have to distribute that negative 2 to get rid of the bracket. So this negative 2 times x squared times 2x and times 1. Now, this negative 10 is not in the bracket, so I don't distribute that. So we have negative 2x squared minus 4x minus 2, and then we actually still have that minus 10 on the outside. I kept that in black. Now we can actually combine all of our like terms because we have no parentheses, no brackets. We just combine everything. We started with y, so we're going to end with y. Y equals negative 2x squared minus 4x minus 12, because this part will go together. And as you can see, the original a value was negative 2, and our a value on standard form is also negative 2. That's how so you just got to remember to distribute the two parenthesis sets before you do anything. So parentheses, brackets, and then combine like terms. This last one says the equation of a parabola is y equals x squared plus bx plus c with the vertex at 2, 5. You want to find b and c. Well, the thing is, it doesn't say ax squared, so what's up with the a? You actually have a value for a. Because it doesn't say the letter a, you have a number here. You actually know what the number is. A is equal to 1. If we want to write the equation, we don't actually have the full equation. We want to have numbers just like we had over here. We have a vertex, but we don't have a random coordinate. So we have our h and k. And then we always want to try and have a. So our h is still is 2. Our k is 5. What's our a? Our a is actually 1 because it didn't say the letter. A is 1. So we can actually put this into vertex form and then just distribute it. So let's put this into vertex form. We have y equals a is 1, parentheses, x minus h is minus 2, parentheses squared, and then plus k, which is plus 5. So we're going to follow the same thing we just did. We have to put it into standard form so we can find b and c. So we have to make sure we multiply those first. Now the 1 on a won't affect anything, so we don't even have to put the brackets. We can have it as 1 bracket, and then x minus 2 bracket plus 5. So it's the x minus 2 part that got written out twice. So now we're going to distribute. We're going to have our 1 bracket, x times x times negative 2. So we have x squared minus 2x. Then we have negative 2 times x. Negative 2 times negative 2 is negative 2x and plus 4. Close bracket, plus 5. So in our bracket we have x squared minus 4x plus 4, and then plus 5 on the outside. Now that 1 there, when we distribute it, so we will just have x squared minus 4x plus 4 plus 5. Combine our like terms. We end up getting y equals x squared minus 4x plus 9. This is standard form. So b is equal to negative 4, and c is equal to 9. This is actually what our question is asking. So again, if your a value in the original problem is your a value in your vertex, is a value in intercept form, the a value is the same throughout all forms.